Previously, we covered blind OS command injections, where the command was getting executed on the target server, but we were not getting the result of the command execution in the response. Therefore, we used commands that will delay the execution of the application to verify that the target application is vulnerable to a command injection. Now, in some cases, you might encounter blind OS command injection, where the command is going to be executed on the target application, but it's going to be executed in a new thread. So you can imagine the yellow line in here is the main application, and once you inject a command into it, it's going to be executed in a new thread. Therefore, if you use a command to delay the execution of the application, similar to what we did in here when we used the sleep command, that command is going to be executed in the new thread and it's going to sleep for 10 seconds. But the web application is going to continue running without any delays, and therefore, even though your command is getting executed, you'll have no way of validating that because there's nothing for you to observe to tell you that your command got executed in the background. Let me show you a quick example of this. The vulnerable feature is the submit feedback, so I'm going to go directly to it, and we're just going to submit some dummy data. And in a real life scenario, you want to send it, observe the result, and then intercept it. But you already know the sequence now, so I'm not going to keep doing it. I'm just going to turn on my interceptor and I'm going to send it. We have the request in here, and I'm actually just going to right click and send it to the repeater so I can continuously modify the request in here and analyze the response and try to discover vulnerabilities based on that. Also, as mentioned, you want to test every single value that is being sent after the equal sign, but I know already the vulnerable parameter right here is the email. So we're going to test it similar to how we tested the previous vulnerability. So we did or, we put the command, which was sleep for 10 seconds, and we did or at the end. So in a normal scenario, I would try with comma first. I would try normal commands and see if I get the response, but I already know that I'll get nothing in the response, and I already know that this works from the previous example. That's why we're going straight away with this, because we're covering a completely different point. So I'm going to click send, and as you can see, I got the result instantly. Unlike what happened in the previous example, where the application slept for 10 seconds. And that is because, as I mentioned earlier, this application is continuing to run in the main thread, and the command that I'm injecting, the sleep for 10, is being executed in the background. And therefore, there is no clues for me in here to tell me that my command got executed. Therefore, to get around this, you're going to have to use a command such as the ping or the nslookup command to cause the target web application to send a request to another server that you control. And then, by observing the logs on the server that you control on the cloud, you'll be able to see that the target web application has made a request to the server that you specified, indicating that it executed the command that you injected. You could create your own hosting on the cloud, and I cover how to do that in my cloud course for free, and you'll be able to test for such vulnerabilities. So you'll just have to inject the ping command to whatever address that you're gonna have for your server. But because this is a lab that is available for everybody on the internet, it's a little bit more restrictive. So the people that created this lab configured it specially to only work with Burp Suite. So in a real life scenario, you should be able to use your own server and just run the ping command to your own server. But because this is a lab that is made by the people that created Burp Suite, it's restricted to only work with Burp Suite. So I have the pro version, and I'm going to use the collaborator feature of Burp. So you can get that by clicking on Burp and click on Burp Collaborator Client. This feature allows you to generate a domain name. So if I click on copy to clipboard, I'm going to get a domain name that I can make requests to, and I'll be able to see the results easily in here. So instead of having to create your own server on the internet and manually looking at the logs, I can simply click on copy to clipboard. It's going to create a domain name for me that is available to anybody that is connected to the internet. And let me show you quickly. If I open up a web browser and paste the link from my clipboard, you'll see that the request is going to be valid and you're just going to get a unique token. And if I go back to Burp, you'll see that it's telling us that somebody, which is myself, has made a request to my Burp collaborator link. So if I actually click on the request as well, I can see that there was a DNS lookup. So somebody pasted this link in their URL bar. I can see the IP that generated that request, and I can say the date and time. So I'm going to clear all of the results in here. I'm going to do Command A to select them, right click and clear. And I'm going to paste the exact same link in my injection in here. So instead of doing sleep, I'm going to do an NS lookup. So this is a command that can be used to map a domain name to its IP. And the way you use it is you type the command name followed by the domain name that you want to query. And the domain name is going to be the domain name of your own server. Or in my case, it's the domain name of my Burp collaborator. So I'm doing NS lookup, the domain name of my Burp collaborator right here. If this target web application is vulnerable to an OS command execution vulnerability, it's going to perform the NS lookup to this particular domain name, and therefore I should see the result in here in my collaborator. So I'm going to click on send. And we're going to go back to my collaborator. I'm going to click on poll now to refresh the results. And perfect. As you can see, we have DNS requests being made to my collaborator domain. It's given me the IP that made these requests. So this is the IP of the server that is hosting the target application. And this will serve as proof that the target web application is vulnerable to a command execution vulnerability, because we managed to get it to execute the NS lookup command, and we have a proof of that command being executed because the web server did actually send a request to the server that is controlled by us, and we can see that we received the request in here. So again, in a bug bounty scenario, this is more than enough to display that the target web server is vulnerable. In a pen test, you can inject commands in here that will send you a reverse connection to your own computer. And from there, you'll be able to interactively control the target web server and possibly compromise the whole network. And I do cover all of that in my website hacking course, but it's not really relevant when it comes to bug bounties, because what you have in here is enough to prove that the target is vulnerable.